Welcome back to Area Diesel Service. Today we have another exciting collaborative effort with fellow YouTube content creator FarmCraft101. If you've come to us from John's channel, you probably know what's inside this box. If you didn't come here from FarmCraft, please go over there, check him out, give him a thumbs up, tell him that we sent you. For those of you that don't know, inside of this box is a fuel injection pump and a set of injectors out of what we're going to refer to as Large Marge.
Be sure and tell them Large Marge sent ya.
So, as we understand it, Large Marge is a case 170B Excavator. I don't know the year. I'm going to guess maybe late 80s, early 90s. This is a large machine, checking in somewhere in the 70,000 pound vicinity. She is powered by a 6-cylinder 374 cubic inch or 6.1 liter air-cooled turbocharged Deutz diesel, specifically a BF6L 913C, affectionately known as a Deutz 913 in the industry. Not a tremendous amount of these engines in the States, but a bunch of them in the world, and they are renowned for being very reliable and robust engines. I believe John said the hour meter on this machine was somewhere in the 7,000 hour range.
I don't trust hour meters a whole lot, but that one says 7,200 hours. They could be accurate. It could also be 17,000 for all I know.
Interestingly, this machine says case on the side, but this was back during some of the merger and acquisition from Case, and I believe this machine was technically a Poclane, French manufactured machine, and they put a Case paint job on it, thus the Deutz air-cooled engine, right? This thing was manufactured in a much different part of the world and imported into the States. The reason that it's here is we have a lax power and smokes black situation. Generally, with those complaints, we would lean towards at least an initial inspection of the charge air system, right? Turbo plumbing, intercoolers, things of that nature. Black smoke is obviously a rich condition, and rich condition generally resulting from a lack of air, not necessarily an overfueling situation. John's given this thing the farmer rebuild, and we want to get back to a good solid baseline. We've experienced pretty great success from our YouTube efforts and the YouTube audience. One of the questions is, well, how does it work? Or people are reluctant to reach out, or they've never dealt with a company that does this type of service before. So the process is very simple. Contact us and let us know what you've got going on. You can call us, you can email us, you can chat with us through our website. We'll set you up in our computer, and then we'll issue you an RMA number. We call it an RMA number. Some people call it an RGA number, a processing number, a case number, whatever. You'll write that number on the box with your components inside. Then when we get the box, the receiving people will see the number, pull up the case in the system, and now we know what we've got, why it's here, and it's a critical part of the process for keeping track of everything and making sure we know what's coming and when, who it's for, and what is to be done. Just like this situation, John reached out. I got some problems. Here's what I'm working on. Here's what I'm experiencing. Okay, here's your RMA number. Write it on the box, ship it in, and we'll have a look. Please make sure that your components are packed well and will survive the trip. John went above and beyond. He's got some protective caps to make sure stuff doesn't get where we don't want it. He's got rubber bands and sandwich bags capping off everything important. And a set of injectors here. When we receive your components, we've got a very simple write-up form to get this stuff back to the production department or to the rebuilding department. We're going to go through the form. We're going to document who it came from, when we got it, what it is, write down all the numbers, and then we're going to do just an initial assessment that the customer has included the fittings. Our goal at Area Diesel is to do the best possible job that we can and provide a high quality customer experience. And it starts right here. If I don't document on this write-up form that the customer sent these fittings, by the time this thing gets all the way through the pump shop and back out the door, sometimes we'll forget that these fittings were included with the pump. Customer will go to install it, and they'll get ready to hook the lines up, and they'll say, "Where's my fittings? I can't finish my job. I ain't got no fittings." There's an additional widget here. It looks like a fuel inlet device of some sort. I'm gonna say it goes right there. We probably took that off. So that might be, I remember talking to John, that might be the supply to the cold start assist system on this engine. Not real sure. The takeaway at this point is we're going to document that we received this component so that we keep our eye on it, keep it in our possession, and that it goes back with the pump to the customer. This is a Bosch 6-cylinder A-Size injection pump. We refer to this as an A-Size, and it has an RS style governor, so ag or off-road style governor on this pump. Some supply pump here, hand primer here, so nothing really out of the norm except perhaps the application being a little bit uncommon for us in the Midwest or in the US. Throttle lever, shut-off lever, sediment bowl, supply pump, hand primer, aneroid. This one does have aneroid hold-off, electronic device there that waits to see oil pressure. Nothing that we haven't done here before. Again, engine driven here, camshaft through the bottom of the pump, tappets and followers and lifters and springs, operating on barrels and plungers, injecting fuel out to the specific engine cylinders, and then all the rest of the magic that happens inside of these pumps. We'll show you some of that throughout the process. Not my cup of tea. I won't pretend to be the inline pump expert. We'll show you some of the highlights, clean it up, tear it down, inspect it, estimate it, rebuild it, calibrate it, paint it, ship it. On the injectors, these look at first glance pretty rough. We have significant barnacles on the injector nozzle nut. These look like they've been sitting on the floor of the Atlantic Ocean for a while. Honestly, I'm more concerned about rebuilding this set of injectors than I am this injection pump, and these have a very low number of components inside them, but they are completely hammered. They do not look good. The other thing I'm noticing, I can't say I'm super familiar with this particular injector. They've got a hold down component on them. Well, it had a hold down component on it, and that one is completely chooched. This one is whammied and right behind it. That one looks better. The other thing, we've talked about this before, we're always looking for clues. We're always looking for indicators. This injector is not like the others. It's not like the others in that I can see combustion up on the body of this injector, and I can't tell you at this point exactly why we're seeing that. The other thing that I can see, and I see that on all of them, but it looks to me like there is orange RTV under the copper nozzle chamber gasket. It does not call for orange RTV under your nozzle chamber gasket. Clearly evidence of combustion up and past the injector. I don't know if John picked that up or if he was experiencing any of that. Undoubtedly was happening. The bodies look like they might just be complete boat anchors, so may have to do some snooping and digging. We've got some other components for the engine on Large Marge that we've got to round up, so hopefully that stuff is in by the time we get these components through the process and meet you back at the parts counters. No chatter. close to the bottom of the spec on opening pressure. So that's injector number 2, 0 chatter, stream instead of atomization. Specification is 180 bar. It's a little low, so also garbage. It looks like it atomized a little better, but still 0 chatter and really not a proper atomization. A little bit higher on opening pressure, but still test bad, time for service. You saw us pop several of them off. No sense in spending any more time. 4 of them were completely hammered. 1 of them we already disassembled, and we're not going to bother going any further, right? These are spent. We'll move them to the next step of the process. Cap off the openings, blast them with an abrasive media, clean them up. Part of the holder that we're going to keep, we'll buff that, clean and polish, clean up the other components in the solvent tank, sonic cleaner, whatever the appropriate cleaning method is, and then we'll get the new retaining nut and the new nozzle, get these smalls cleaned up, and then we'll meet you back in here. The master has performed his craft, and we have beautiful, freshly remanufactured injectors. O-rings, chamber gasket, return line coppers. Those have been reassembled, calibrated, and ready to go. Under the strict supervision of the actual expert, I'm gonna slap one of these back together for you, just to kind of show you the internals and simplicity of this device. This is the main injector body. Injector line from the pump screws on here, and fuel gets pumped into the injector from the injection pump. That fuel comes down through the injector, through that passage on the side of the body, and it goes through intermediate plate, which gets pinned to the body. So these pins go in these holes. That little hole lines up with that, and you can see it passes back through the intermediate plate there, and it comes down into the nozzle, travels through the nozzle, and it goes up under and operates, I believe, here, and that pushes the pintle back against the spring pressure, which is calibrated and determined by the thickness of the shim. Relatively simple in theory and operation. We're going to put the body in the fixture plate there. Shim goes down in the body. Get your dental pick and have a look and make sure that it seats down flat. Spring goes in next, and it's ambidextrous. Doesn't matter which way goes which. Pop it in. Spring seat goes on top of the spring. Intermediate disc. This is actually the sealing surface between the body and the nozzle. So if you do go inside these injectors and you go to cleaning, be cautious of these surfaces. These are lapped precision surfaces, right? So the rest of it we hit with a wire wheel or a buffer, but stay off of here or this thing will leak like a sieve. So line up your pins and your fuel passage, and then again the alignment pins are here, fuel passage here. Sometimes the nozzle orifices are not symmetrical, and alignment of these pins is critical because the injector may come into the cylinder sideways and may do the spraying down. So it's always important, don't just yank these pins out and slap this dude back in there. You'll melt down a cylinder or you'll have smoky engine. Pop the nozzle onto the intermediate plate. Slide the nut down, kind of give the nozzle a twist, make sure that the pins are still lined up, and then screw that down, and it'll start compressing that spring against the shim. Torque that down to spec, right? So this one has gone back together again, new nut, new nozzle, and we put the original thickness of calibration shim back in it, and we're going to load it up in the pop tester and see where we're at. We're looking for chatter, and we're looking for about 180 bar, which is I think around 2600 psi's. I'll bleed it out. You can already hear it chattering. I don't know if that's picking up on camera. We may stick the mic. Hopefully that demonstrates the chatter, and you can see beautiful atomization, right? So no more stream, no more urinating. It's beautiful. It's chattering and it's atomizing. We're going to open the valve to the gauge, and we're going to sneak up and see where it cracks at. Right there, about 190 or so. So perfect. That's it. That's as much as I understand about it. Injectors are whipped. We do have to order centering bushing, but these are whammied or busted. But the hard part's over. We'll get a set of those coming, tag these up, and we'll knock this pump out. We are in the teardown room. We are in the cleanup phase, and we've already made a potentially minor discovery. We gave this a bath in the pressure washer. We put it in the blast cabinet and cleaned it up. And one of the first things we popped off was the aneroid. Boost pressure comes in here, and it basically holds off fuel until you get some boost coming up and get some air in the engine, so you don't get that initial puff of black smoke, right? This is very early emissions, the control device. But inside door number 1, we find a considerable amount of the proverbial shmoo, right? This is nasty, and we should not be finding this inside our injection pump. Fortunately, there's a diaphragm here. We may not have any of this inside the engine, but this is shmoo for certain, and it's nasty. We don't know exactly the source. It almost looks like this hole was left unplugged, right? There should have been a boost line screwed in there. And we got some shmoo and some barnacles down inside of that connection as well. And it kind of bears resemblance to the injectors we talked about, right? That's got barnacles on it. So starting to wonder if Large Marge wasn't potentially underwater at some point, or exposed to some weather, or left with some holes open or something. But we've got barnacles and shmoo in places we don't want it, and we're going to keep tearing down and let you know what we find. So we'll get this thing scattered. We'll bring you back for kind of a final assessment. We have scattered this pump, and it's actually in pretty good condition. The main pump housing all looks just fine. The camshaft, right, this is a critical component. This is what goes around and operates on the barrel and plungers. Lobes and everything look fantastic, especially considering this is at least a 7,000 hour machine. We talked about the barnacles in the aneroid cover before. It's cleaned up the best we can get it. We do not like it. We'll see if we've got one of those in the hoard. I'm sure we do. The diaphragm was chooched. You can see that was the barnacle side. That was the inside. Underneath the diaphragm on the inside of the pump, the aneroid itself was in good condition. We did have some contamination, ingestion. Not real sure if that was left open, but definitely some crud in there. The other half of the aneroid actually cleaned up just fine, so no concerns there. One piece of carnage. You can see during the disassembly process, we popped the supply pump nuts off the studs on the side of the pump, and the ear busted right off, so it just fell apart. We're assuming it was cracked from the get. This is now junk, thus the reason we didn't finish cleaning it up. We'll have to look into that and see what we can do. Delivery valve holders look fantastic, right? They cleaned up just fine. The heart of the pump, this is the barrel and plunger, and this is the actual pumping element from the inside of the pump, right? So the camshaft goes around, operates on some tappets, and this is the actual pumping element, and the rack turns it to change where this helix lives in regards to some of the ports in the barrel, and that's what dictates how much fuel this thing bites and injects. These plungers look to be fantastic, especially considering the number of hours that are on this thing. Throttle shaft, we've looked at these many times. You guys have seen them. This one you can just faintly see where the seal rides, but you can't pick it up with your fingernail. It's fine. one area of significant wear. This is the flyweight assembly out of the pump. This dude gets driven by the camshaft in the pump, and as it turns faster and faster, centrifugal force operates on these weights, and that's what governs the pump. These governor weights and all of the springs and levers and magic that happens inside the pump, but this is the governor weight assembly, right? You remember the balls out thing from the old steam engine? Same concept. And this particular pivot, I don't know if we can get in close, but it's chooched. That's got too much play in it. So that'll cause erratic governor, or your engine won't operate smoothly. Intermediate housing, governor cover, that stuff looks good. Side panel, thrust bearing, all of the smalls and bolts and widgets. Nothing really to report there. So now we're going to get the bill of materials, order up some parts, check availability. Really all the hardware here, with exception of the supply pump that broke, is technically satisfactory to go back for another cycle of life. If the barrel and plungers are reasonably priced, readily available, we will make that investment. Honestly, this pump was in good condition. We have determined parts availability, looked at the pricing, created the estimate, contacted the customer, and we've been given approval to proceed with the repairs. We're going to show you a couple of things. We're going to talk about the game plan. The slop in the pin on the weight. This is the solution. We'll show you one that we've repaired here. And you can see this brass or bronze looking sleeve. And then you can see where it's been peened to retain that. And that's been done on both sides. Harvested, salvaged, repaired, remanufactured, what have you. But this component eliminates the concern that we had with this component. Aneroid cover we took to the glass bead blaster, and it cleaned up to an acceptable point. We'll still check the hoard, see if we've got one, but I have no concerns. Again, this is just exposed to boost pressure and operating on the diaphragms. No concerns there. Barrels and plungers were both available and economical. We wanted to get 6 matching, brand new, authentic Bosch barrel and plungers. And then the only thing remaining is really the supply pump. So we talked about that earlier. The ear on the supply pump was broken. That dude is unobtainium. We finished cleaning it up and blasting it, and we've taken it back to the machine shop. They assure us that they can repair that component no problem. I'm not sure what it's going to be. Probably a TIG braze, and then skin it back down to the original surfaces. We have Large Marge's heart on the operating table. we have acquired all of the necessary components to perform this overhaul. We're going to get out of the way and we're going to let the actual expert step in here. We'll bring you through some of the assembly process. We've got some other videos where we've done the full feature director's cut, but I don't think we're going to get in on all that for this go round, but we'll give you some of it, and we are going to slap this baby back together. We've made some progress on the assembly of this pump. Jakeb has camshaft installed, looks like tappets, springs, barrel and plungers, delivery valves, holders. The entire pumping arrangement of this pump has been installed, and he's made it to one of the first setup points, or the first potential adjustment points of this pump. And what we're going to talk about is thrust play on the camshaft and camshaft drive protrusion. The thrust play in this cam, in this orientation, right, axial play, we can feel it. We got a clunk in there, and specification is 0 backlash, but we want to creep up on that to where we get 0 backlash with the least amount of shims possible, right? We don't want to get this thing into a bind, but we've got to get that thrust play out of it. To do that, you can shim it either in the front behind the bearing retainer or in the rear behind the bearing. You shim it behind the bearings, right?
This pump here, yeah, the camshaft, it's got shims on both bearings. So you take one out of here and add it to the front. It'll move it this way.
Move it. Or add them to get rid of the thrust play.
Yep.
So he's got to take the cam all the way back out.
Yes.
Does he have to completely disassemble it?
No.
You just take the
bolts
bearing
out.
retainer
Yep,
off.
take them 2 bolts out.
Okay.
Yep. Cam will come out. Change them.
Okay.
Yep.
Gary, resident inline pump expert, was hearing us in the background. My explanation of shim location or shim placement was incorrect. Protrusion is correct. Thrust play is excessive. The addition of the shims will go behind the front bearing as to not adjust protrusion, but to take up the thrust play. So, like I told you earlier, I am certainly not the expert here, but that dude is. Gary's been here for
45 years.
45 years and has been building these inline pumps the whole time. So he wasn't even paying attention and knew that I had made a mistake. So we have a special tool. It's got the camshaft taper machined into it. And what we're looking for is the amount of protrusion from the camshaft. And we do that by installing the special tool and taking a measurement between the tool and the mounting flange. Protrusion is critical depending on the relationship of that gear to the drivetrain. the injection pump timing will be changed. It's not a straight tooth gear, it's a helical gear. If it is protruding further and further out, it's effectively changing its relationship in regards to the rest of the drivetrain, the rest of the gear train. You're going to pull the cam back out, add some shims to take up the excessive play without modifying protrusions. Just kind of an interesting step one critical build part. So we'll pull the cam, we'll do that again, and then we'll move on. If we hit something else of interest, we'll check back in. Jakeb has whipped this baby back into shape under the strict supervision of Gary. Went back together as planned. Rack stayed free throughout the process. No curveballs. Everything went pretty good. A little bit higher up on the list of things that I'm not qualified to speak about is the calibration and validation of this Bosch injection pump. But I'm going to try and give you a little bit of an explanation because it's kind of loud in the test room. We've got the side cover off because of the adjustments we're going to have to make during calibration. and then that supply pump. We use the supply system from the test stand during the calibration process, so this will get installed and buttoned up prior to shipping. Mount this thing on the test stand, right? Get all the lines and connections hooked up. First thing we have to do is set ourselves up to be able to phase time this pump. And to do that, we have to know when cylinder number 1 is going to start injecting fuel. We'll get a dial indicator right on the tappet, and we'll take a measurement of lift. And when we achieve the lift specification, we will know that number 1 cylinder is at start of injection, or port closure, as you might have heard it. When we determine that, you'll see on the flywheel of the test bench that there are a degree indicator around the circumference of the flywheel, and we will adjust that to 0 degrees. 6-cylinder engine, so every 60 degrees, or 1/6 of 360, you'll have another injection event. Individual cylinder quantities, so the specification, the calibration specification will call for turn the pump at 1,000 RPMs and let it run for 500 strokes, and you should see X amount of fuel fill up in this graduate. So you run the pump and you have a graduate for every cylinder, and you want to make sure that those are all delivering equally, also to keep you from having a clattery, vibrating engine. If you are not balanced with delivery, then you go into the control segment, and you can see he's got some reference marks already put on there, and you can individually adjust the relationship of the barrel and the helix in regards to the rack. And now we're going to set them individually for quantity of delivery.
You got a 121, 121, 124, 120, well, 118, but we turned that one up. 122, 122. So we're about within 1 cc in each cylinder. That's about what I want. So we're going to go to the low idle, and we're going to remember 3 is low and 4 is high. So we're going to go low idle now. We're at about 13 for 1, 4, 5, and 6. This is 13. For our 3, we're at 14. So 1 cc difference is not going to make a massive issue. We'll probably just use it. However, our 2 is at a 50. A little high. We're going to drop this one down to hopefully a 23 at least. We're going to drop this one down to a 20. The only difference is with your low idle, these are a lot more touchy. So like the movement I would do at my high idle would move these like 10 cc's at a time. So I barely moved that one. I gotta move this one even less. These are all like 1 to 2 cc's. These are about at 120, which is like almost perfect. My number 2 is a little low, but it's a little high on my low idle, so I'm going to leave it. Bumper screw, which is this because it has a spring right here. Now we're actually going to set low idle. Now 325, which is our 326, which is fine, at 6.8. So we're going to screw this bad boy in. Now we're just going to double check it and make sure that with our bumper screw set and everything, we are A-okay.
Earlier, there's a calibration process for this. This is called the aneroid, and it is an early emissions component. Really, all this does is hold off the fuel delivery until the engine starts making enough boost or air or supplying enough oxygen to burn the fuels. We have a measured and metered amount of boost pressure we can feed the pump. Unlike a rotary pump, we have an individual pumping element for every cylinder. We have individual quantity delivery adjustments. We have phase timing and all these other widgets and magic contraptions that we've spoken about. This is a super cool contraption. Back in the day, can you imagine engineering this thing? I think when inline pumps started, it preceded computers. It blows me away every time that we get into one of these projects, the level of complexity in these contraptions. Usually anytime that complexity goes up, reliability goes down, but that is not the case with these pumps. These are very, very robust and reliable, beautifully engineered contraptions. That's as maxed out as my brain can go on inline pump theory and operation, but just know that there are many experts at Area Diesel who specialize in this and focus on this and this only every day. We have made it. We're at the end of the road, and we're going to just do a quick wrap up here and summarize what we have done. Injectors, I know you saw. We got rid of the barnacles, new nozzles, nozzle nuts, and shimmed and calibrated, back in action, much better atomization and appropriate pop-off pressure. So injectors ready to rock. Probably the star of the show is John's injection pump, right? The heart of Large Marge. Here is the finished product, fully rebuilt and restored for another cycle of life. Cleaned it up, tore it down, inspected, acquired some parts, rebuilt, reassembled, calibrated, painted. Here she is, turd brown and ready to go back to get reinstalled. We have here a new oil cooler for John's engine. You've probably seen on his video, he pulled this off. He did a leak test. He had a leak in the cooling fin area. This dude, I'm sure, in Europe is reasonably priced. In the States, they're pretty proud of it. We got a quote through the actual Deutz distribution network, and our cost was almost $5,000.
Can I say it slow for you? Look, I need $5,000. Read my lips. $5,000 is what I need.
As you know, we've got many friends in the industry. We've been around for a long time. We were able to come up with an authentic Deutz product for a significantly more reasonable price. I know that you can get that on Amazon. I know your cousin Daryl can find it on eBay for $300. And if that's the type of product you're after, we find no fault, but that's not really what we're trying to do here. Authentic OEM replacement oil cooler. Large Marge has got a little bit of seepage from her private parts, and we've got full engine overhaul gasket kit. We suspect oil pan and sump on this thing to be the primary culprit. By the time we piece together the gaskets to seal that up, we rivaled the cost of a full overhaul gasket kit. I have no doubt he's going to find use for many of these other gaskets and seals. He's not done going through this thing. This is just kind of a gift bag, goodie bag, care package, and it has a large variety of random copper gaskets and dowdy seals and umbrella seals and some banjo bolts, the things that you can't get at your local chain parts store. If you went to your case dealer and bought that arrangement of widgets for this machine, I'd hate to guess, but you'd probably rack up several $100s worth of gaskets and seals. Shouldn't theoretically need any of those, but we want to give that to John. He can throw it in his junk box. Next time he needs a 10-cent gasket, he won't have to make a 2-hour trip to get it taken care of. This stuff's going to get properly packaged and safely secured, and we'll get this shipped out to John so he can put this dude back in business. The million-dollar question, as per usual, what's the damage? And it's hefty this go round. Oil cooler, brand new, authentic, Deutz OEM, checking in at $2109.38. $2,000 chunk of aluminum there. No charge on the goodie bag. Injectors, significantly more expensive than normal. These are as good as brand new OEM. We've got a set of the hold down alignment bushing headed to John as we speak. Those injectors checked in at $1.40 a copy. 6-banger, that's $840 on your injectors. Injection pump, a lot of labor went into this. Ironically, still not as expensive as this engine oil cooler. Injection pump checks in at, we had about $450 in parts, and we had 10 hours at $1.25 for $12.50. Injection pump, high quality rebuild, $1,700. And the last thing is the engine overhaul gasket kit, $287.82, so $300. The grand total, you're talking about a $5,000 affair. Significant investment being made by John into Large Marge to restore her to service, and we're happy to help. If you haven't already subscribed, please consider doing so. Just learned that Large Marge's lungs are also going to be coming our way.
This is the intake side, and I think it fails the farmer test. I don't know how much movement comes across on camera, but I'd say that thing is moving at least 30 thousandths. More than it should. Doesn't rub the housing when I spin it.
The turbocharger from Large Marge is clapped out. We should be bringing you a video on rebuilding that unit very soon. If you like what you saw, do me a favor, give us a big thumbs up. Go down below and leave us a comment. That helps feed the algorithm. I want to ask that everyone go down in the comments and give thanks to Jakeb. Jakeb had a lot of time in this project, rebuilding it. And Josh on the injectors, right? Tell those folks thanks for letting you follow along. And also behind the camera, Mallory, who has more time invested in any of these efforts than the rest of us combined. Do me a favor, go down below, tell the team that you appreciate their efforts. If you find yourself in a situation where you need help with injection pumps, fuel injectors, turbochargers, or any other diesel engine component, please don't hesitate to reach out and let us know. We are a fair and honest, long-standing organization who really prides themselves on taking good care of the customer. So I know that Uncle Earl can get on Amazon and get some of this stuff for a considerable less price, but you're not going to get the support and you're not going to get the quality that you'll find at Area Diesel Service. If you need something, please don't hesitate to reach out and let us know. You can call us at 800-637-2658. You can log on to our website at areadieselservice.com, where you'll find a large amount of high-quality information and the ability to chat instantly with a diesel engine expert through the button in the bottom right-hand corner of your screen. You can drop us an email at parts@areadiesel.com, or you can stop by any of our locations in Iowa, Illinois, or Indiana. And if you're not in those areas, don't let it stop you, right? These YouTube efforts have turned up lots of opportunities throughout the entire U.S. and actually throughout the world. So give us a call. We'll cut you an RMA or an incident number, and you can ship your component in. We'll take care of it and ship it right back. Go over to FarmCraft and tell them
Large Marge sent ya.
So that's it. Thanks for watching.